Hi everybody, it's great to be here at the Colorado Springs Tech Conference. I actually love Colorado, but it's been so long since I've been. So it's a great opportunity for me to record this video for you and share with you some of my insights about software understandability. Let me get started by introducing myself. My name is Liran Haimovitch and I'm a co-founder and CTO at Rookout. I'm an advocate of modern software methodologies such as Agile, DevOps, and Lean. Before founding Rookout, I spent a lot of time doing cybersecurity, an entire decade, as doing research, development, and team leading, product management, and so on. And I'm also a huge fan of hiking, scuba diving, and so on. So let's give you a quick overview of what Rookout is so that you have a bit of an understanding of where I'm coming from. So Rookout is a platform for live data collection and debugging. Rookout uses a technique we call non-breaking breakpoints, which essentially allow you to set kind of like the same breakpoints you do in a traditional debugger, except those breakpoints don't break. They translate into live instrumentation that takes place inside the running application. And using those non-breaking breakpoints, you can collect any type of data you want on the fly with no extra coding, no redeployments, no restarts. Just click on the line you want to get data from and instantly see the stack trace that brought you to that line, the variable values within that line, and so on. Very cool, very quick. Now, along the way, we learned a lot about how software engineers work, how do they write code, especially how do they debug code, and even more so, why do they debug code? Which brings us here to this talk about understandability. And let me start with a quick example. You might be asking yourself, what is understandability and why is it important? I'm gonna be spending a lot of time today discussing about what it is and what you do about it, but let's start with why it's important. I'm sure many of you have a lot of experience writing code, some of you are more seniors, some of you not so much, but I'm sure there are so many simple exercises that you've gone through, simple tasks you've gone through so many times, whether it's reading and validating a JSON or other data structure, sorting a list or an array or a tree or whatever. And I'm sure if I were to give that task to most of you, or a task like that, you can probably do it, I don't know, in half an hour, maybe a couple of hours. And at the same time, what would happen if I were to give you the same task, such as sort a list, within a very large and complex system that you might not be familiar with? All of a sudden, this simple task of sorting a data structure becomes that much more complex. You have to understand the context of it. What data structure is it? Where is it being stored? Is it in memory? Is it in a database? How is the data structure encoded? What's the division of responsibility between client side and server side, various components, various services? How often is the data structure accessed? And so on and so forth. So if I were to give you, go into this screen and now resort this table, all of a sudden there is a lot more you have to understand. And so instead of just making this a half an hour or task or 2 hours task, this task can easily take you a couple of days or even a couple of weeks, depending on how well you understand the system. And that's exactly what understandability is. Helping you measure how well do you understand the system, or in the understandability, how complex to understand is the system, so that you are better equipped and better able to do your job. Now, I really like this quote by George Bernard Shaw because to me it speaks so much of software engineering. Imagination is the beginning of creation. You imagine what you desire, you will what you imagine, and at last, you create what you will. And In software engineering, with the power of code, we can create almost anything. And so imagination truly is so powerful and so fundamental to what we're doing. And yet, we're seeing that 68% of teams and organizations experience the fly blind or fly slow dilemma. Essentially, do I fly blind? Do I lack data? Do I lack understanding of my software? Do I make changes and hope for the best and pray that those changes will work properly? Or do I fly slow? Do I spend a lot of time and effort to continuously investigate my software, add more logs, add more metrics, read through the docs, consult other people, and do I spend a lot of time and effort to understand the system I'm working with? Because that's really the dilemma. Do I go without understanding? Do I go on a hunch? Do I make guesses? Or do I spend a lot of time and effort understanding? And the reason so many organizations suffer this dilemma is because their software has very poor understandability. On the other hand, for 32% of the organization, they don't have that dilemma. Their understandability is good. For those organizations, engineers can understand software without spending so much resources and without getting stuck with fly blind or fly slow. Just fly fast, just understand what's going on. Which brings us to the definition of software understandability itself. And like every good artist, I stole the definition of software understandability from the financial industry. In the financial industry, financial understandability or understandability in general is about how do consumers are able to understand the reports they get from the providers, whether it's your insurance provider, pension provider, and so on. How well can you understand the report to figure out how much money do you have, how much are you paying them, how much will you get one day, and so on and so forth. So building on top of that, here is my definition for software understandability. Understandability is the concept that the system should be presented so that an engineer can easily comprehend it. So if a system is easy to understand, you don't have to spend a lot of time and effort, you can just move ahead. If a system is hard to understand, then you go back to the fly slow or fly blind dilemma. Either spend a lot of resources and fly slow, or don't spend the resources and fly blind. Now, before we dive deeper into what makes a system understandable and how can we improve on that, let's discuss first what makes a software application or a software system. What is an application comprised of? So, first and foremost, an application is comprised of source code. Obviously, that's what all of you were probably gonna say. That's what every software engineer said when I asked you about it. Software is my code, and obviously that's true. Software is definitely comprised first and foremost from code. But on top of that, there's a lot of other stuff, such as configuration and state. So configuration is how am I configuring my application, how many instances are there, if I have multiple config options. For instance, if you use a TLS or SSL, the secure protocol for communication over the web, then those protocols support hundreds of encryption methods, hundreds. And many of them are secure, but many more are no longer secure. There are a lot of vulnerabilities and issues with some of the older protocols. And it's one thing saying I'm using TLS, which might or might not be secure, but if you know exactly which cipher, which encryption algorithm you're using, then you are much better able to determine is this secure or not. And you also have state. And like the famous joke, or not so much joke, the famous truth goes, almost every complex systems can be fixed by restarting or rebooting it. Tells you so much about the complexity of state and its impact on the system. Whether it's state in memory or on disk, whether it's in database, or even cookies. How many times did a problem go away by clearing cookies, by clearing state? And understanding the state of the system is critical to understanding the application as a whole. The runtime environment. You might be using Node or Java or Python. Just think how the same code behave or read with a different version of the language. Not to mention what happens if I'm using a different multi-threading model, if I'm running on-prem or in the cloud. Is it client? For instance, in JavaScript, is this code going to be running in the browser or in Node? The same source code might mean different things and behave differently in a different environment. We have service dependencies. I mean, today you might be working with a whole bunch of other services. There might be internal services to your organization, such as identity or other components. There might be third-party services, whether you're using Stripe or Sentry or other tools. All of those have a huge impact on what your application as a whole is made of and how it's able to do its job. And last but not least, maybe most importantly, the inputs and the outputs of the system. Whether you're developing an API or a command line interface or a web UI or anything else, the way the users interact with your system, the inputs they are providing, the workflows they are executing, that makes a huge difference. And at the end of the day, when all of this comes together, the source code, the configuration and state, the runtime environment, the service dependencies, and the inputs and outputs, only that as a whole makes your application work and make your application meaningful. And when we discuss understandability, we have to take all of that into account. Just relying on the source code itself, being ignorant of the inputs and outputs and configuration and state and so on, that's not going to get you very far in understanding how your application actually works. Now, going back to the financial industry, they have actually created four very different criteria for what makes a report understandable. Now, let's go ahead and steal from them yet again and use those same criteria to define if a software application is understandable or not. The first criteria is complete. Is the information I'm providing to my software developers complete so that they can understand the application? Obviously, providing the full source code is very easy, very straightforward. If you want a developer to understand the application, he has to get a full source code. But he also has to know what's the production state of that environment, some level of access to the database of what's stored in there, how are we configuring the application in production, what inputs customers are sending to that environment, and so on and so forth. We need information concise. I mean, source code might be in the millions of lines of code, databases might contain billions of records. We need some way to stream the data, to slim the data, to make it more concise, to make it easier to digest for our users, in this case internal users. We need to make the information clear. I mean, let's say you have 1 billion records in your database. You want to reduce it in a way that's very clear, very simple. So you might want to tell the user, the software developer, we have 1 billion records. Half of them belong in Europe, half of them are in the US. About 2/3 of them are women, 1/3 is male, and so on and so forth. To make it very clear. When looking at source code, you want to make it readable, you want to make it easy to understand, and so on. And last but not least, you want to make it organized. You need to get the user to start with a high-level overview of the system and be able to dive deeper into various parts of the system as needed to collect more data. I think the best example for that is the IDE navigation, where you can go to definition, find all your colors and so on. Those are great tools that allow you to navigate through the information in an organized manner. Now, as I'm going through this, many of you might be thinking of other similar terms that to you might be very close to understandability. So let me tell you what understandability is not. Understandability is not complexity. Yes, a system might be very complex or it might be very simple, and complexity will definitely hurt understandability, but they are not the same. Think of the same application, a very complex, let's say, financial application that does a lot of transactions. On the one hand, you have the source code and nothing else. On the other side of things, you have the source code, but you also have input examples. You have a reference manual describing the logic of the system. You have an architectural diagram of everything that's been going on. And you can have a whole set of other tools that help you manage that complexity. A fairly simple system that's poorly documented, and we're going to discuss other tools, might still be hard to understand, while a very complex system where there is a lot of tooling for understandability provided might not be that horrible. Understandability is not readability. Readability is very well connected with the second criteria we've defined, clarity. If something is readable, then it's probably clear and so on. But readability doesn't cover all the criteria we've discussed. Just because the source code is clear doesn't mean the source code is available, which we discussed as completeness. And so, yes, an application can and should be readable, but that doesn't necessarily make it understandable. And last but not least, there's been a lot of talk over recent years about observability. Observability is super important, and it serves SREs and ops people very often in observing the system, in experimenting from the outside. As you might know, observability comes from physics, and it's about being able to determine the internal state of the system based on external observation. So you might be able to say, is my system working well or not, just by looking at its outputs. But when it comes to observability, you assume you have some knowledge, you have full knowledge of how the system works, and right now you're just trying to measure, is it working as expected? Rather than diving deep into the system, trying to take it apart and understand every single part of it. Obviously, observability can help understandability, and understandability can help observability, but they're two different things. So, what can you do to improve understandability? What can you do tomorrow to make your software easier to understand so that the changes you're trying to make, whether it's developing a new feature or fixing a bug, can happen faster, can happen easier? How can you be more efficient? So first, it would be great if you could minimize complexity. How can you approach that? You can start by cutting back on requirements. Every requirement we add, whether it's a functional requirement, such as supporting a new flow, or a non-functional requirement, such as higher availability or more security, makes a system potentially more complex. Second, hire the best developers. By having superior developers, they will be able to find simpler solutions to the same problems. Utilize the highest level building blocks you can. If you are using Java, use the latest version available, or even consider using Kotlin or Scala. Try abstracting away as much as possible using libraries, frameworks, cloud providers. Any piece of complexity you can hand off to somebody else is less complexity you have to handle. Apply software engineering principles. As I'm sure you've been taught from Introduction to Computer Sciences, good software design, good abstractions are there to minimize complexity, and they can definitely help you here as well. And last but not least, practice Agile and DevOps. Don't over-engineer, don't over-design, don't over-implement. Start small, start simple, and build on it based on real user needs. Now, well, these are all great tools for minimizing complexity, and the less a system is complex, the easier it is to understand. Keep in mind that many of those tools are not available for existing systems. Once a system has been written, once a system is out there, there is only so much you can do about those items, and so it might not be applicable to some of what you're looking for. So we do have other options. For instance, our second tool is knowledge. The more you know about the system, the more you learn about it, the easier it becomes to make those changes. I mean, the system might be complex, but having the knowledge available about how is it complex, why is it complex, and how to approach it can make it that much easier. So start out by learning about the application, read the source code, collect input examples, see the state in production, and so on and so forth. Speak with former colleagues, speak with existing colleagues, run the system in test environments, collect as much knowledge as possible, and as you collect it, don't forget to document it. Don't hold it all in your head. Write it down, whether you're using SharePoint or Google Docs or Notion or just a pen and paper. Just write it down, keep it for you, and once you get it written down, share it. Share it with your team. It can be in one-on-one sittings. It can be just sharing links on Slack. It can be by recording lectures and talks about the system. Share the knowledge, spread it around so that as much people can benefit from it. The third option you have is better development environments. Think of it as a tool. Developers are spending their day-to-day lives in the development environments, not in the production environments. The closer the development environment is to the production environments, the more accurate it is, the better they're able to learn from it and actually understand the real system, rather than understanding a fake system that might or might not be related to the real thing. Start out by replicating the tech stack. Starting with simple stuff such as use the same language versions, the same compiler versions. If possible, enable them to spin up test environments in the cloud or in the data center, and build the closest environment you can. Use high quality test data. That's super important and also sometimes quite challenging, but collect information that is close as possible to what's happening in production. If you're able to record user sessions, that's awesome. That may not be possible due to compliance or security reasons, but you might be able to record sessions done by internal employees or by test users you've created for that purpose. But collect as much high quality data so that when observing the behavior of the system using that data, your engineers will be able to learn as much as possible. And last but not least, you have to manage environment drifts. Once you've set up those labs and engineers can play around in those labs, take apart the system, observe it, understand it, work with it, that's inevitably going to change. Whether you're scaling up your production system, adding new services, adding new dependencies, adding new use cases that use different pieces of data, make sure to keep the development environments, the test environments, as close as possible. Keep updating the tech stack, keep creating new test data, because otherwise those environments are going to lose their effectiveness. We've also mentioned observability in the past. Observability tools are awesome, and if your organization is already using observability tools, they can also benefit your ability to understand the code. Observability tools include stuff such as logging, tracing, metrics, and error tracking. Now, all of those elements are great because if you're looking at the system from the outside and you're seeing a bunch of logs or metrics, they can definitely help you understand what's going on and how can you benefit from it. If you're seeing an error, that can definitely help you understand what's wrong. But at the same time, you have to keep in mind that observability tools by nature are very rigid. You can only add a log line by adding code and redeploying. You can only add a metric or change error tracking by changing the code and redeploying it. And that can take a while, often a long while, anywhere from a couple of hours to a couple of months, depending on your software development lifecycle. And that's kind of the downside of observability tools for understandability. They are very slow to respond, and the reason they are slow to respond is because the classic clients, the classic users of observability tools are ops and SREs, and for them the questions don't change that often. An ops person cares about, is the system up, what's the latency, what's the error rate, and so on, and doesn't often care that much about the inner working of the business logic of the system, which we do care about when discussing understandability. Which brings us to the last section, understandability tooling. Those are tools that were literally made to enable you to better understand the software you're working with. Obviously, the first and foremost is the traditional debugger. I mean, whether you're using a CLI debugger such as GDB or Delve, or you're using something fancier integrated into VS Code or IntelliJ or Visual Studio, being able to walk through the code, see it line by line, see every stack trace, every variable value, stop on first chance exceptions, and so on and so forth, even allow you to change data and see how the system responds to it. Those are all awesome tools that allow you to see the inner workings of the system. Now, many environments do support debuggers, and if you have, as we've discussed, if you have set up a high quality development environment with high quality data and high quality work, then you might be able to use those debuggers and benefit from them. Unfortunately, in many newer environments, whether it's huge monolithic applications or complex service mesh environments, or even just a lack of high quality test environments, traditional debugger doesn't cut it anymore, which brings us to the next gen debuggers. Next gen debuggers allow you to connect to code as it's running in any environment, production, staging, cloud, on-prem, distributed, and so on and so forth, and get a very similar experience to the traditional debugger without worrying too much, and while making sure you meet all your security, compliance, operational, performance needs. And that's what tools like Rookout are there to do. Help you see into your code, help you understand it step by step without wasting too much time and effort. So really, that's all I had for today. I hope you've learned a bit about understandability, why it matters, what you should do about it, and I hope it provided you some ideas of how you can improve it with your own projects. Feel free to reach out to me on Twitter, on GitHub, with questions or comment about it, and feel free to check us out online at rookout.com and check out our product. Thank you very much and have a great conference.